Okay, well, thanks everyone for coming. We're going to be talking, Buram and myself, Paul, we're going to be talking about Flowable BPM, and it's a transactional BPM, and we're going to talk about how we've got that operating on MongoDB, and also talk about how you can use BPM in microservice orchestration and things like that. So that we're going to cover 3 topics in the talk. Introduce you a bit to Flowable if you don't know about Flowable already, and what it is, what it's about. Talk about some microservices and the application of BPM to microservices and why they're relevant and why we're seeing a lot of people using BPM for microservice orchestration these days. And then we'll talk about our experiences of trying to get a transactional, traditionally relational database-oriented technology running on a non-relational database, MongoDB. Now, why is Flowable interesting? Flowable is interesting, BPM is interesting for solving a number of business problems. And you can think about this in terms of case and business and process management. Case management, the type of problems you're trying to solve, well, anything to do with digital transformation projects, digitalization, somewhere they will be using case management or business process management. For case management, it might be for client onboarding, for dealing with a social services claim, thinking about a particular incident and how you manage an incident, and it describes the elements that need to be dealt with within a case. And often as part of that, there's business process management. How do I solve a particular problem? What are the steps I need to follow to achieve something? And business process management is usually about how do I organize the actions and behavior of people and systems and get them working together, usually in predictable, repeatable ways. So it's either because this is best practice and I want to use BPM to capture the best practice, or it's I'm in a very compliance situation where I'm in banking or I'm in healthcare where I have to follow procedures that need to be auditable and everything else, and I need to show that I'm doing things properly. So these areas of problem are ones that BPM and case management are very powerful for. There's some open standards to cover those. There's CMMN, which is a standard for case management. There's BPMN, which is a standard for business process management. And there's DMN, which is a standard for decision management or a form of business rules. So these open standards, there are other products and platforms apart from Flowable that support them. They are open. They are standards. So you can sort of once you've learned them, you can use them in a number of different scenarios. And what we provide is within Flowable is an open source project that provides engines that execute those standards. So Flowable, the open source project, is a fork of Activity, and it was forked by the Activity developers. It's a very active project. There's lots of contributions, lots of activity on the forums. You can go and see that for yourselves. Go to the GitHub source node or to the project page on flowable.org. And what there are engines to execute BPMN, CMMN, and DMN. And the way the engines work, really, in a nutshell, what they are is you have these models that describe your business processes or your cases or your decisions in a way that business analysts and business users can understand and see visually and communicate with each other around describing their problem. And those models can be deployed onto the engines, and those engines execute those models. And how you can interact with those engines is through a whole set of different APIs. There's different technologies, different APIs that can be doing that. So really, I mean, I guess what more could you possibly want to know about Flowable as a business person?
Yes, as a business person, that's why you're saying it, right? So we're at the developers conference, so this is where I'm taking over, and we're going to go a bit more into the technicalities, right? So when you heard Paul talking, you might have think like, okay, so this is about drawing stuff on a screen, boxes and arrows, and then running it on a server, which sounds awfully like visual programming, and we don't like visual programming, right? Well, I can guarantee you we don't like it either. What we do is we give you the best of 2 worlds. So we take this model that is really the common ground between developers and between business people, and I'm speaking from my own experience, that really cuts down the number of requirements documents needed. We've been in many projects, there's a ton of requirements documents, and by having like a visual model of stuff, it doesn't cut away all the requirements, of course, but it really is a common ground where people between business and developers can meet. On the other hand, what we do is we take this model and we give you a very developer natural way of working with these models. The APIs, you can write unit tests, you can do pretty much anything you do with any normal Java framework, so to say. You can do that with Flowable, and I'm going to show you that just now. Now, if you don't believe me, what you can do if you go home or you just open up your laptop right now is you can just take this bit of code. This is a Spring Boot example with Flowable, and pretty much just does the code needed to create a REST API that when you hit it with the post, that will start a certain process instance from a model you have, right? So you got this model that is a representation of what your business does, and you want to start that through what we call a runtime service. The only thing you need to do is you got to put the Flowable starter on your class pod if you're using Spring Boot, if the Spring Boot starter, the Flowable starter, and then the magic happens. There is a process engine is created, services get injected, as you can see here, you just simply auto-wire it. If there's a database, it will be used. If there's transaction management, it will be used. Now, normally, and the plan was that I was going to show you to do this in live coding. However, I got one of these fancy new MacBook Pros with a ultra-thin keyboard called a butterfly keyboard, and as of recent, the spacebar only works 1 out of 2 times, which really sucks if you need to do a live demo. I tried it and it's just impossible. But anyway, I'll show you if there's time at the end. I'll show you live, how this can run. But trust me on this, 2 minutes, and that's all you need to create a service with a process model right there. And as Paul said, one thing we see a lot these days is that users and customers that we have, they're moving, or they've already moved into this microservice kind of architecture, or they're thinking about it. And using Flowable in these kind of architectures is really quite simple. I'm just going to touch briefly on the kind of ways that we've seen them being used. Now, the first one is the obvious one, is kind of like the orchestrator, right? It's the one that everybody thinks about when you have, or you talk about a BPM engine or whatever, is that you have a couple of services, doesn't matter what they are, and you need to have some component that orchestrates these, right? And then the engine can pretty much define visually how to do that and give you the way of doing this in a really efficient way. Second thing is that there is an alternative to that first kind of pattern that we see sometimes, is that instead of directly calling these services, there is kind of like an event thing in between, an event kind of queue where you put things on. The engine consumes events and it puts new events on that drives the other services. That's an alternative to this orchestrated pattern. One thing that we also see quite often is that you've got a number of discrete services. They do something very low level. They have like a function they expose, but on themselves, they don't really know anything about the system, the ecosystem that they are in. And what we see that Flowable often is used for is to consume these services, but to expose a new service into the architecture. So really, these are just very simple services. They don't know anything. This might be like a customer service. This might be like a lookup service. Doesn't matter. Then Flowable kind of makes sense of these services. And lastly, what we also see quite often is that they simply write a service with Flowable and expose that as a low-level kind of service onto this architectural world. Now, one thing to mention is that when we were looking at that previous example, right, this simple example here, you don't really want to use a workflow engine or a BPM engine for this, right? I mean, you can easily write this yourself. But you got to imagine that you have tens or even hundreds of process models, case models, whatever, rules, and you want to execute 1,000 of them an hour, a minute, 1,000 a second, whatever. That's really where the Flowable engine comes in, and it's really where it shines. It's really where you want to use an engine like this. If you will write this yourself, which you can, of course, it's code, you're going to end up with stuff or rewriting stuff that we've done and we figured out a long time ago and made it very efficient, as I'll show you later on. Now, talking about microservices, the thing that we invested a lot in the last year is actually kind of decoupling and, so to say, microservicing our own architecture. Now, if you see this thing, you might think, whoa, what is that, right? There's a big engine. Now, trust me, if you boot this boots up very fast. It only takes kind of like 4 or 5 megabytes in memory if you boot it up. So even if it looks big, there's really small kind of components. Now, what we've done, definitely the last year, is we kind of decoupled all of the low-level services that we use into very distinct, discrete kind of services that can run on themselves. So we've actually have a few things, prototypes that we've actually run, for example, the variable service on itself, or we run the job service on itself, and they all together comprise into a bigger engine. Now, just for your information, there's a couple of cool use cases that we can do with this, and I will talk about that later on. So, as Paul said, we have a lot to cover, and I just wanted to briefly introduce you to Flowable, just to give you an idea, put in your head what it is. And from this part on, we'll really focus on the MongoDB, kind of our journey towards how we ported, so to say, the engine onto a MongoDB kind of database persistency. Now, one thing to take into account is that the Flowable engines, they really rely on the transactional semantics of a relational database because we guarantee that we move from one stable state to the other stable state, and whatever happens in between, we can kind of guarantee that we move in a business atomic kind of way. And that's why it's in between quotes, because of course, if there are systems involved, technical systems, it's really hard to make that atomic, and it's probably impossible to make that atomic. So we're really talking about business atomicity here. Now, often people, when they start using Flowable, then they start thinking about, oh, that's just cool, I don't have to worry about anything here anymore. Well, no. It doesn't free you from, thinking about service failures, about error handling or whatever. But with Flowable, you at least have a model, a transactional model that backs you up and that you can, fall back to if have to reason about these things. And we started thinking about this MongoDB journey, about this adventure, I think it was like in January or February when they announced it, that they were going to add transactions to 4.0, which they did. Eventually, MongoDB, in end of June, I believe, they released MongoDB 4.0, and it had transactions. That is really, given the context that we're this kind of engine that moves atomically stuff around, we rely on transactions. It was really interesting for us to have a look at how this looks like on MongoDB. Now, very short kind of history for people that don't know MongoDB. MongoDB is a JSON store. It's part of the NoSQL family. It's a JSON store. You put JSON documents in, you query through JSON, everything's through JSON. MongoDB was founded in 2007. And the early days, I'm sure you remember it, the early days it was known as the dev null database, pretty much because what you put in could just be gone, be corrupted. Luckily, since then, they really got their act together, and they really made sure that the defaults are good, that it's just a database you can rely on. And key to the whole transactional story is the acquirement of the WireTiger storage engine in the end of December 2014. It was a default engine in 3.2, but the WireTiger engine really shines for the transactional features. There's a really interesting series of videos on YouTube from MongoDB where they very low level explain how they use this WireTiger to build these transactions into MongoDB, which isn't easy if if you're around from 2007 and suddenly you have to slap on transactions. That's not easy. To really put the link there at the bottom, really interesting videos series. It doesn't have the views it deserves, I think. So if you're interested in that kind of stuff, please have a watch. All the code that that we're talking about today is on GitHub. It's on the Flowable MongoDB repository. We released the first kind of alpha version last week, together with the 6. And this is a mistake. It should be 6.4.0. And I'm just going to put some words in your head just to understand the code. If we're dive into the code later on, that you kind of can follow. So if you do an API call, the API call that we had back in the beginning, right? Start a process instance through the runtime service. That there's a couple of layers that you go through when it happens. Now, first of all, when you call this service, you go through kind of a command pattern. It just wraps the logic into a command and then gets passed on. Beneath that, there's the agenda. On the agenda, there's operations. And you place operations on this agenda. This agenda kind of loops. It's kind of like a run loop from your browser, for example, from the JavaScript engine. It just loops until it doesn't have any operations and it executes. This is really the meat of the Flowable engine, so to say. But it needs data. And to get that data, it's going to use the entity managers to get data. And this is really the high-level kind of functions. And the data managers are really the low-level, let's say, CRUD services. This is really a get, find, update, delete, and these kind of things. This is really where it kind of makes sense from a business point of view. Now, just putting these words in your head, not really important that you know exactly what they do, but you'll see it in the codes that's exactly what we will be doing when we do the MongoDB thing. Now, looking at the MongoDB transactions, they actually follow a very familiar pattern. If you, for example, use GDBC, right? They quite follow a pattern that is familiar to Java developers. They have the concept of a client session. So the moment you start a transaction, you get an object back, which is called client session, and you have to pass that object into each of the new operations afterwards. And all these operations are then part of the same transaction. I'll show you that in the code after this slide, I believe. Now, this matches Flowable's low-level session concept very nicely, as you will see, because on the lowest level, now under the data managers there, we've got kind of low-level sessions, we call them. It's like a transaction-level cache. There's like a object where we gather all the data that's going to the database, all the deletes, all the updates, all the inserts, and we kind of flush them at the end. So that's also a session. And that concept matches very nice with the way they've implemented the transactions on MongoDB, which is really nice to see. So this is the moment I'll switch to some code. And let me, yeah. All right. So, oops, not this one. Sorry. Here we go. All right, so like I said, I've the data manager, that's really a low-level kind of CRUD operation. And it has everything you could imagine from a CRUD kind of service, insert, delete, update. Now, most of it is implemented in the abstract superclass. Let me zoom in a bit. MongoDB, it works with kind of collections. So you have JSON documents and you put them in what they call a collection. So what you see is that everything will go through this collection, which is, it's not like a table, but just for the ease of explanation, let's assume it is. So what you do here is, remember, we're working with sessions also at the lowest level. So what we do here, for example, I'm doing an insert of some entity, and you see we've got quite a bit of entities, as you can see on the left-hand side. So for example, let me zoom in and swap to this method. That's going to make things more clear. Right. So what we do, remember I said that we are keeping all these objects, all these entities until the end, and then we flush it. And there's a reason for that, because that way we can optimize it. So suppose that you've got like an insert. Let's take a process instance. You got an insert at the beginning, but the process runs until the end, and you have a delete, and the two cancel each other. So that's why we only flush at the end and then save a network hop to the database. So what you see here is that what we do is we gather all these entities, right? So this is basically a hash map. We gather all the entities. We're going to ask for the collection, which is part of, and then we're simply going to loop through them. We're going to map them. Now, don't expect anything fancy from this mapper class. Let me just show you one. Process definition entity mapper, for example. This is literally, we've been toying with a couple of frameworks that allow you to do this automatically. So far, we really haven't found anything that fits our thing yet, or is still active. There's a few known ones out there, but none of them are really still active. So what we do for now is we simply do it manually. But if somebody has a good suggestion, please let us know, because this is just, not really sexy code to write. Pretty much, you have a document. This is a JSON document from MongoDB itself, right? So this is simply from MongoDB. And what you do is we map in and out. That's it. So that's what's happening when we were having this discussion about the inserts. We just loop through them. We just go to the collection, we stream it, and we map them to the entity, to the document, and then we simply insert it, right? We insert it in the collection. And you see here that we pause in the client session. And that is the way that we actually bind it to the transaction. So when this MongoDB session, which is a class from us, is created, pretty much at the beginning of your API call, you can see that we start a transaction. And then we keep this client session locally. That's why this concept of a session is quite easy to build into Flow, but it really fits our architecture very well. And you got to imagine this client session like, if you know Spring and transaction management from Spring, you got to imagine it like the thread local from Spring that's being kept somewhere, and that's what we do with the client session from MongoDB. Anyway, so that's a bit of the low-level stuff. Now, of course, how does that look like on the relational bit? Well, let me show you the difference. Here we go. So one of the things that we often do is like querying for data. Well, turns out that the MongoDB kind of thing, you see it's quite long, but in the end it doesn't do a lot. It simply keeps a list of filters, and the filters, as I said in the beginning, the filters are a JSON document on itself. So we query by putting in a JSON into MongoDB. What we do here is nothing different from, let me just show you the counterpart in, definition XML. Just show you the counterpart in a relational model, and you'll see, here we go, if I go down a bit, we use, for the people that don't know this is my Batis. So it's kind of like a very thin layer on top of the GDBC low-level kind of code. It's simply you express it either in XML or in Java, and the XML can do something more than the Java sometimes, so that's why we're using the XML here. But you see that it doesn't really do much more than what we were doing in MongoDB. And that's why it actually, when we were reporting or writing this MongoDB integration, it really was easy for us to kind of map this quite quickly, as you can see. So then you see pretty much all the work that we've done in that Alpha 1 release is adding all the things, and there's quite a bit of things there, is adding all the support for all the things we have. And of course, this is not, let's say, the optimal way. I'll talk about it later, but this is a one-on-one translation, right, from relational to MongoDB. And there's a few kind of tweaks we already made, but you can feel that the MongoDB kind of model, the JSON model, might need some other data structure compared to the relational one. But the first goal of us is to port it and then to optimize it. And I'll show you later on a few kind of interesting tidbits that we already figured out that were quick wins to do. So that's our current goal, so to say. So currently we're really kind of churning out alpha releases, probably doing one, well, probably next week. adding way more kind of support for all kind of entities. What we do is we use a test suite of our regular engine. There's about 3,000 tests in there, and we run them against the MongoDB kind of setup, and then we see what fails. And the goal is to get that, of course, to a full green status. Once that's done, we'll churn out the beta release or stable release. We'll see at that point. Thing is that, as I said, we're doing a one-on-one translation right now with some optimization along the way. But after the first stable release, we're really going to look into kind of how can we optimize it for MongoDB. Right. Of course, this I explained it like a nice story. There were quite a bit of challenges along the way. I mean, the end result now, you look at it, it's like, oh yeah, of course. But to get there, we had quite a few of difficult moments, so to say. Now, this particular exception is really a dreaded one for me because I spent half a day on it figuring out what was wrong. And the server just gives you a write conflict. And I think the use case was kind of like, I'm inserting a process. The process has a timer. It has to, do something after a certain amount of time. And anyway, I'm getting this exception, and I couldn't figure out. I mean, we had a few people on Slack and just calling and trying to figure out what it was. Now, remember, I tell you the solution now. Remember that I told you that this client session, you need to pass it into each and every operation you do against MongoDB. And if you're used to the Spring kind of model where that's magically done for you by thread local, you kind of forget about that. You kind of forget in Spring, if you do JDBC transactions and you do JDBC code, that will always be bound to the thread local. Well, not if you're doing it manually like we do in MongoDB. What happened is that in this class, in this MongoDB session, that particular kind of client session is passed around quite a bit. And what happened is that in one low-level kind of, I don't know if it was an insert or an update or whatever, we forgot it. And what MongoDB then does is pretty much, these operations, they're bound to a transaction. Oh, but you're now doing an operation that's not bound to a transaction. And it got very weird exception with a write conflict. So it was actually trying to write something that then later on was done in a transaction, and it just said, well, I don't know what to do with this. It makes sense if I explain it to you right like this, right? But like I say, it took us half a day to figure out, like, oh, damn it, it's just one little word that we forgot to do. So in a way, it's also kind of showing where MongoDB comes from, because it was a non-transactional system for a long time, and it now is. So it had to have some backwards compatible API, and the way to do that, of course, is to add new methods with that client session. If they would have gone for transactions from the go, of course, the API would have been very different. But see, this is a bit of the challenges. I just wanted to put there because, I tore my hair out that day. Another thing, of course, is if you're doing relational for a long time, as we're doing, you kind of take joins for granted. You kind of assume that you've got kind of tables and, I need something from here, or just join them and happy merrily go away. That's not that easy if you don't have joins, because everything is a JSON document and there's no joins. And it is a lot more work as a developer to guarantee data consistency, because normally if you use a relational model, you put in stuff and you kind of assume that the schema check will do it for you. Foreign keys, null constraints, whatever, right? That's exactly why we use a relational model for. Well, if you don't have that, it's a lot of work to guarantee that you don't screw up your data. A simple example very simple example of that join kind of thing is, remember that I told you about that start process instance. Here we go. I told you about that start process instance on the runtime service. So actually just starting a process instance. Well, what it does behind the scenes, it actually fetches the latest process definition from the database, and it's going to use that. Now, it needs to do that because it could be, if you're running in a cluster of different servers, it could be some server has already deployed a new version of that process, so you don't know on this server that you actually have the oldest version, or not the most recent version. So you need to have that latest. Now, that we do that by a simple select star from process definition and then do a subselect for the latest version. Easy. It's a fast query in the relational model. You can't do that in MongoDB. So what we had to do in MongoDB is it's always exchanging time on insert against time on a query. So what we do here, it's not that hard to imagine what the solution is. We a bit bigger maybe. We kind of have a new specific MongoDB version. So this is the regular one. This is the one that we also use in the relational model, so to say. Here we go. Just a regular POJO. And we simply extended it with a latest kind of key. And what we do now on the insert, normally in the relational counterpart, you just insert it, go, done. Now in MongoDB, what we have to do is we actually have to find the latest process definition, the latest version that was in the database deployed, and we got to change it. We got to update that flag. It's not the latest anymore, and we have to make the one that we're inserting now the latest. That's what's happening in this particular bit of code. Now, this, of course, means that we also need to have something like optimistic locking, which we have on the MongoDB session, because if you insert all of these things together in the same transaction, you got to guarantee that nobody else, no other server has at the same time deployed some other version. So there's a bit of work there, and that's what we've done. Anyway, just to show you kind of, and we have this kind of pattern in a few places. Interestingly enough, is that it also started to show us places where we can optimize the relational model. So this kind of pattern actually could be, and we have to try it out, but this kind of pattern could very well be that it simply is faster also in the relational model, right? That this denormalization is better for both, and so we'll see. But the thing is that instead of one insert, you now have a select, a find, and you have an update. So, always a trade-off. But we'll get to that trade-off and performance later on. Now, luckily, over the past years, we've done a lot of work on making Flowable faster in many ways. And one of the things we always keep in mind is that the most expensive thing you can do is a network hop. So if you can avoid going over a network, that's a win-win. You can do a lot of work on the local, let's say, local server, but if you have to go over a network, then you lose a lot of your performance. So many of the things that we've done over the last years with Flowable is a lot of denormalization, like really duplicating data. And because we own the engine, we know the engine pretty well. We own our own code. It's kind of constrained. That's what I mean. Is we know if we denormalize, if we duplicate data somewhere, we also know exactly where to delete it again. So it's quite easy for us. We also did a lot of prefetching. Like if you hit something, you just grab a lot more data and you get it back, because that network hop is expensive. And if you can get more data back in one go, you might need it, you might not need it, but it always outweighs doing an extra network hop later on. And lastly, entity counts, which is kind of like denormalization. Pretty much we store on many of our entities that we store, we have extra columns saying how much relations do I have against other tables. For example, a process. We store how many variables you have. We store how many jobs you have. We store all kinds of counters. Now the reason is, if we have this counter, it sounds counterintuitive. If we have this counter, you know that you don't need to do another select. You know you don't need to do another delete. Sounds silly, but this way we could really optimize the engine heavily and really push it to the extreme. And luckily, I'll talk about performance in the next slide, and luckily we did all these things over the last years, because that's exactly the kind of things you need to port it easily to MongoDB. So we were kind of lucky that we were doing the same things that were needed for MongoDB over the last years, which happens to be also beneficial for relational kind of use cases. Now, the question, of course, that everybody will ask immediately is like, how does it perform, right? I mean, am I just able to swap MongoDB with another database? So that's why we did a very simple kind of benchmark on Amazon AWS. There is the link at the end. The code for this is at the end. The code for this is on the GitHub repository. So what we've done is quite simple. We've taken a service that just will continuously is going to create process instances. It's a very traditional machine, 8 cores, 32 gigabytes of RAM, so nothing too fancy. Then we have same kind of server, 8 cores, 32 gigabytes, 100 gigabyte SSD for Mongo, and we have the same setup for Postgres. Now, people that are interested in Postgres, we didn't take it a simple Postgres. We kind of tweaked it because the default Postgres just doesn't take a lot of memory, so we gave it all the resources it needed. Now, what we've done is we brought the process from one stable state to the other, right? Because that's exactly what the engine does in a business atomic way. Now, what we've done in this particular benchmark is that we brought it from the start to kind of the wait state here. So it would start, do some service, would go into this, it's called a sub-process, would spawn off some branches, parallel branches here, a couple of services. It would go here, waiting into the parallel gateway. This was a service, and here it would stop. It would wait because this is a user task. And here there's also just another timer, just to have some fun. If you look at the relational model, what this means data-wise, is quite a bit of data from this to this. You're talking about 6 executions, 2 user tasks, 1 historical process instance, 11 steps needed, historical activities, 2 historical user tasks. Now, these historicals, they are there because the Flowable engine keeps an audit log of all these things. So it's quite a big use case for using a process engine like Flowable. So that's why this is there. 31 variables, so we inserted a few variables here. This was generating a few variables, and there are a few, in total 31 variables, 31 historical, and 1 timer. So all of these is 1 row in the database. So 6 rows, 2 rows, 1 row, 11 rows, 2 rows. So a lot of data. So just to give a taste of what the difference in performance is. And just what we did is we had a thread pool of 8 threads, and we just went and created a million of these process instances, just because a million is a nice number to put on a slide. Now the results were the reverse of what we actually expected, which with benchmarks, it's always fun, but also take into account benchmarks are always benchmarks. They take it with a pinch of salt. They're just a snapshot in time. It could be that we that we have a certain kind of preference for something. So our goal was not to know which is better. Our goal really was, is it acceptable for us to have as an alternative? But what was strange is that when we were testing locally and when we were discussing it amongst each other, we were thinking, okay, the relational database is going to be quicker in inserts, and MongoDB is really going to shine when it comes to querying, because that's what MongoDB is known for, right? Well, it was completely the opposite. So low is better here. So this is the time in milliseconds to insert 1 billion process instances with the 8 threads that we were having. So basically, MongoDB was faster in inserting these, and Postgres was actually faster in doing 5 million queries. So after we've inserted it, we actually did like a query for each process that we were having. So we did 5 queries, like give me all the thoughts, give me all the variables, and then looping over them and doing some other query. The code for that is, in the GitHub repository. It's all open source, so you can check it out, and we didn't make a mistake, hopefully. And so yeah, the thing is that we're trying to figure out why this is. It could be that a relational database, of course, has to check all foreign keys, all kind of constraints, which MongoDB doesn't have to do. So could be that that's the reason. We're still investigating, and we will hopefully put out the blog about our findings soon about that. Now, when you look at these graphs, you might think that that's actually quite a big difference, right? Relatively, it is a big difference. However, you got to take into account that if you calculate this, if you divide the total time divided by 1 million, we're talking about 2 to 3 milliseconds something each, right? So this actually, the difference between the MongoDB result and the Postgres was less than 1 millisecond. I don't know the exact numbers. I think it was 0.40-ish something milliseconds. So even though the graphs look quite relatively big, the difference was actually very, very small. And we haven't even started optimizing nor the relational nor the MongoDB. Now, of course, this is really good, but relational DBs like Postgres has done some great work in the last years. If you're interested in, we did a very extensive benchmark a while ago. We did a very extensive benchmark on the relational models on AWS. And there we really, tried out and really pushed how far we could go with the Flowable engines on a relational database. And you'll see if you read that, we're talking about thousands of process instances a second. We could completely, from start to the end, completely do in the same second. So, we've pushed the relational model quite far, right? So having this kind of result isn't that strange, because over the years, we really found ways to optimize that to the max. And we're still finding ways, by the way. We're still working on something right now. So a conclusion here about these graphs is that there's 2 kind of things that are impressive here. Is that one, I think it's impressive the way that MongoDB added transactions, because they are in the game for quite a while, and they slap transactions on, and it actually works very nicely. We didn't have any case of data loss. We didn't have any case of corruption. We didn't have it worked like you would expect from an ACID-compliant transactional database, which is technically, if you ask me, quite impressive. A second thing is that it is actually the numbers that we were getting were actually quite good. They were relatively the same ballpark numbers as the relational one. So, which leads us, the conclusion that we're actually, trying or going for is that for us, it is really a valid alternative right now for running Flowable on top of MongoDB. Now, there are a few limitations with the current implementation of the MongoDB transaction support. Currently, you can only read and write to the primary, meaning if you have a cluster of nodes and you set up a replica set, that's the second limitation is you can only have transactions on replica sets. So if you want to do transactions, currently they only support read and write to the primary. So it kind of defeats the purpose of setting up a replica set. But If you watch the MongoDB World 18 kind of announcements, and it's very small, but basically there's a roadmap from 4.0 to 4.2, which is kind of probably about a year or something they were talking about. And you see that all these things, there are things that they planned to improve the transactions or to add new features. For example, they don't have support yet for sharded clusters, which is a really interesting kind of thing for us. I'll talk about it in the next slide. And so this journey is not over yet. I mean, we're going to follow every release that will come out, and we're going to add new features as they add new features. But it's pretty cool to see the maturity that is already in there in the solution right now. Now, this brings me to the future kind of work that we're planning to do, is that MongoDB is designed for horizontal scale. It's really easy to set up a few servers, make them talk to each other, and spread your data across a cluster of nodes. I mean, yes, Postgres has something, partitioning of tables. MySQL has kind of, master, slave, master, whatever. All databases have something, but if you've ever done that, and I've done that many times, that's really not fun. It's really sometimes hard to do. And MongoDB just works. You boot it up, find each other, it just works. The sharded clusters, once they add transactions to the sharded cluster, that opens up really interesting use cases for us, because they shard based on a JSON field key. So you just say, this is my JSON field I need to look into, and I'm going to shard on that particular key. Well, that opens up kind of very nice use cases for sharding by tenant. So we have tenant support in the Flowable engine. So basically, you can easily say, okay, these tenants, they go to that kind of service, these tenants go to that, and you really have physical separation of the two. Or go even further. Say, okay, these processes, that's from a high-level customer, they're paying a lot, so you can go to more resources there and just handle the rest there. There is a lot of things here. And of course, the last use case, this is the last part that I want to talk about, is about machine learning. Because MongoDB is this big data kind of thing, whatever that means. But the point is that it has some really good APIs when it comes to streaming and when it comes to reactive, right? And which is really useful, as you will see in the demo I'm going to show you. It's really useful for the use cases if you're talking about machine learning. So what I want to show you now is, what I'm going to do is I'm going to run a lot of processes. I'm going to use the historical data that we gathered, and I'm going to feed that into machine learning. And the goal is actually to see if we can find some human work that is repetitive and suggest optimizations to do that. Now, the process I'm going to use is quite simple. It's not not real for by any means. But basically, what we're going to do is we're going to capture some details. This means that we're going to put a form in front of a user. They're going to fill in name, age, nationality, and these things. There's an automatic check here that will provide some advice. Doesn't really matter for a use case. There's going to be a loan review by another person in the bank, for example, and he's going to decide whether to reject, to accept, or maybe, and then there's another advanced loan review and here. So this is really, we're gathering data, and there's a lot of human work involved, and a lot of human judgment. So the goal of this kind of thing that we were going to show is we want to see if we can optimize or maybe even remove any of these kind of automatic steps and let the people do more useful work, right? Nobody likes repetitive work, so that's what we're going to try to see if we can fix it. So what we're going to do for that is we're going to try to find kind of patterns. The pattern is a decision, a human taking a decision, filling in a form, pressing some buttons probably, and we can see that easily in the process model by finding these kind of these rectangles with the user icon, which is followed by an exclusive kind of choice between up, down, or to the right. And if we find that, what we do is we take that pattern and we trace back to the beginning. We say, okay, if we're here, right, if we come out of this one here, this form, we have this service produces some data, we know which data it produces, we trace back, we have this, we know the form, we know exactly which data will be captured here, and so we can trace back to the beginning, actually have a set of data that leads up to this decision, so to say, and then we can decide, or let the machine learning say whether or not there's patterns in there. So the machine learning will really be used here for finding patterns in these things. It could be there's no patterns, that's fine, then we need to keep it. Or it could be that most of the time, if we have a certain set of data, we know it's going to go up or down or to the right. Right, so people that have seen us last year, we've done similar kind of setup last year. The architecture was there that this is the process service. It was doing this process like over and over and over. It's stored in a database. We were pushing stuff into RabbitMQ, like we were pushing the historical data into RabbitMQ. It was a Spring Boot listener. We were feeding it into Elasticsearch, and then we were streaming it into Spark. Spark is the kind of thing I will use now for the machine learning. And then we have a service that kind of finds these patterns that we talked about, these patterns, and basically is going to kick off, when it has enough data and find the patterns, it's going to kick off a job on Spark. Now, when using MongoDB, this is a bit simpler because we have the process service, still continuously creating process, but all the data is here, and Spark has the features, or the driver at least, the low-level driver to stream this as an RDD to Spark. Now, an RDD is standing for Resilient Distributed Data Set, and it's quite an important concept. You will see it in the code. Quite an important concept. It's pretty much an immutable data set that it's divided over a cluster of worker nodes. And the thing is that it doesn't have all the data, so it doesn't fetch the data unless it's needed. That's why you need a system that can stream, that can be reactive, like MongoDB and a relational database. The support for that is not yet there yet. It might come. They're working on it, as we learned in the last spring conference a couple of weeks ago, but it's nowhere ready yet. So this is really what we're going to do. Now, is this a better architecture than this one? No. I mean, this is just a different kind of architecture. This is for, if you're using Elasticsearch already and you have queues already in place, fine. This is nothing wrong, this kind of approach, but this kind of approach could also use a queue. Right? I mean, we can easily put a queue in between and offload the data to somewhere else. This is just an alternative. Anyway, let me show you what this is all about. Switch to another project. By the way, all the code that we've shown today, all this code you can see here, is on GitHub. And the next slide I will show has a link to it, so you can just at home look at it in easy comfort of your home. Basically, what we have here, well, let me just show you. This is the kind of, if we look at our slides, this is this service here. So the process service is really simple, and you see how simple it is to use MongoDB together with Flowable. Normally, what you would do, you would insert the data source here or the raw JDBC parameters. Well, the only thing we do now is we set a connection URL and some properties that I need for this particular demo. That's it. We create a process engine configuration. From that process engine configuration, we create a process engine. That process engine has access to all the services. Here we go. And there is no difference when using a relational database or a Mongo database. There's no difference once you are past that configuration. So that's the setup. What this thing will do, it will just start. This is a very quick and dirty, as the comments say at the top, a very quick and dirty kind of REST controller where we're just going to start a number of instances. That's it. I'm going to boot this thing up already while I'm talking about. Nope. I'm going to kill it so I can show you it's all real. Here we go. So I'm simply going to run it. It's a Spring Boot 205 application. Nothing particularly spectacular about that. So this is going to churn out process instances, like creating historical data, and it started. So what I'm going to do now is I prepared already. I don't know if you can see it, but what I'm going to do is I'm going to call this REST endpoint. I'm going to start 1,000 of these things, right? So here we go. It triggered a start. It's asynchronous, so it's going to trigger and start it. I've got here Mongo Hub, which is kind of like an application to see the data in MongoDB. So I'm just going to see there's now 3,132 in there. I played a bit before this session. There's new 3,248 in there. See, it goes up gradually. I'm just using one thread to create them. I mean, you could speed it up with having multiple threads, but that's not the point of this demo. The next thing is what we're going to do is we've got this kind of decision analysis. Now, I'm not going to go into this code. This is really what we're doing here is we're doing these steps as we showed on the slide. We're going to find these patterns, user tasks with decisions. We're going to gather the data of the forms. That's really what's happening here. That's nothing more, as you can see in the code here, that's nothing more than inspecting the model that Flowable gives back. So Flowable gives you, as we were talking in the first couple of slides, Flowable gives you a really Java model of working with these things. So this is what you're seeing here. It really gives you a nice Java way of talking about these things. But on itself, it's a lot of data just gathering. The really interesting part is this one here. So what we're going to do is we're going to give this to Spark. Spark is just a machine. Well, just it's a really impressive project. It's has a lot of machine learning algorithms. The one we're going to use here is the decision tree. So what we're going to use is what we want to know is that the human decision can be expressed in a decision tree, meaning like if, else, something like a big nested if, else if needed. So what we do here, let me just show some highlights, is We're going to go to the historical variables collection. And this is where the actual kind of transformation from MongoDB to the Spark specific data structure goes. So what we do here is we're loading this particular Spark context, which is configured to go to the historical variable instances. What we're going to do is this is going to, you see here, it's an iterable. So it's not, the data is not fetched at once. Now, the important thing is here is that this is going to be transformed to, as you can see here, to an RDD, the resilient distributed data set, which is going to be spread across the cluster. It's important that if you have like 10 nodes, it's important to understand that if you have 10 nodes, each of them will get a bit of work. And for that, your data store needs to be able to do streaming and reactive. So that's what we're doing here. Elasticsearch, as we've shown before, could also do that, by the way, which is pretty cool. So what we're going to do first is we're going to group based on a process instance. So simply we're going to get that document. So what comes out of this one is just a JSON document. We're going to group them all together by a process instance. If you have 1 million of these process instances, Spark will make this easily distributable across a cluster. We're going to filter them on some particular, you're going to see we're only interested in ones which are really decisions, which is something that we do here. And then what we do here is we're going to map it to a labeled point. A labeled point is kind of like a vector. Now, every machine learning uses a vector, which is kind of like every point in the vector is standing for a certain variable, and you give a number to that variable, a double, and you pretty much spread. And that's how the machine learning works. It doesn't know about names or ages or nationalities. It knows about numbers, and it reasons about numbers. And that's exactly what we're doing here. Now, let's not go into too much detail as of the time constraints, but that's the only thing we do here. And at the end, what we do here is we split up into a 20% testing thing and 80% to train it. And then we set a few kind of algorithm things. Some of these are all in the documentation of Spark. And you just say, okay, decision tree model, and we'll see what comes out. Let me run this. So this time probably, right. So probably now my thousands have been created. Yep, we're now at 4,000 process instances. And so this is also a Spring Boot app. So you see here, this is the service kind of figuring out what the data is. So it has gathered the data. For example, one of the first kind of forms had a nationality, and there's a couple of values there. So it's kind of traced back from that decision to the beginning. And if we scroll a bit down here, so this is the input for Spark. You see, and this is always it's always a surprise. Oops, sorry. It's always a surprise what the algorithm comes up with, because we only have 4,000 instances. It's not a lot of data to already make a decision upon, right? Normally you would need way more. And it's also random, because I like to have some fun with myself. It's random, so I put random data in. I put random ages in there, put random nationalities in there, right? So apparently it now said, if you're over 50, I'm sorry, you're rejected with 100% probability. So that's random for you. Anyway, when you take these things, this decision tree, what you can now do, and this is the last thing I want to talk to you about, is you can actually now go back and say, well, the machine found out that there's 100% probability that whenever there is a person feeding in, like I'm 51, if that's happening here, that this guy will always say reject. And so in theory, we could swap this out. Now, what we do is we don't swap it out immediately. That would be really evil. What we do is we kind of suggest this in kind of a modeling environment. We say, well, our machine has found this kind of data, and this is why. And it suggests to the user, maybe you should build it like this now, right? So we don't swap these things on the fly. That will be quite invasive. But that's what we do here. Anyway, if you want to see that, I actually have that on my machine, where it swaps the UI, but as we're near the end of this presentation. If you're interested, we're having a boot at the end of the hallway here. If you want to see it, please come and find us. All the source code is on the GitHub flowable examples, and then you just have to click through to the demo JAX 2018. So everything, the first Spring Boot example, some MongoDB kind of examples, the whole machine learning thing is all on here. All of that code is on there. And that's it, just perfectly on time. And we're organizing a community event in Barcelona next month, 20th of November. If you're interested, please join. I don't know if you want to say something more about that, Paul. Otherwise, thank you very much for joining and listening. And have a great day.